Okay, so for the current, it's about 21.3 micrometers and madali nyo lang na makukuha yung current kasi or madali nyo ma-verify na yun nga yung na itong values na to ay tama simply by multiplying this current with the load resistor and your dapat yung makuha is this voltage. Okay, so yung maliit na error na to is not is caused only by yung data points, yung missing data points. So you can increase yung accuracy niya by changing yung tolerance dun sa sa properties ng resistor. Okay. So pag may coupling capacitor naman, ano ang magiging effect? Okay, so anong nakita niyo effect nung nagkaroon ng coupling capacitor? Nakita niyo effect, is first of all, yung resistor voltage bumaba. Okay, so from 9.98 or 10 millivolts naging 9.5 millivolts na lang siya. Okay, and secondly, yung current bumaba din. Kasi kanina kung titignan niyo, kung titignan niyo yung current is 21.7, 21.2, ngayon ang current is 20.149. Okay, and paano nangyari ito? Ano ang effect ng coupling capacitor? Well, pag naglagay kayo ng coupling capacitor dyan, of course, magkakaroon din ng voltage drop dyan. And yung voltage drop ng capacitor is, kung i-measure niyo, it's about 3.2 millivolts. Okay, and you can verify na itong capacitor voltage added to the resistor voltage will be equal to 10 millivolts. Okay. Remember, this is AC circuit, so ang addition is not straightforward. So kung titignan nyo, if you have a calculator now, you can verify na 3.2 millivolts squared plus 9.5 millivolts squared will be equal to 10 millivolt squared. Okay? So, yun yung ano dito. Kasi kung titignan nyo, parang hindi siya, anong tawag dito? Hindi siya straightforward na addition, right? So, ito naman, kaya bumaba ito dahil nagkaroon ka ng voltage drop dito at nagkaroon ka ng voltage drop dito. So, itong voltage drop dito has a corresponding capacitive reactance. Ang capacitive reactance niyan will be equal to this. Okay, yung frequency is 1 kilohertz of course, and yung capacitance is 1 microfarad. So kung ano man yung value nito, yun yung capacitive reactance niya dyan. And i-combine nyo with yung 470 ohm na resistance dito. Okay, it will give you a different current. Okay, kasi dati may 470 ohm ka lang, ngayon meron ka ng dagdag pa na capacitive reactance. So nadagdagan yung total impedance, ibig sabihin bababa rin yung current. Okay? Okay. So yung part 2 ng experiment naman ay yung voltage divider. Okay? Now itong voltage divider naman ito ay yung magpa-power dun sa inyong transistor. So before yung AC, yun yung AC na voltage, yun yung input dun sa transistor, yun yung gusto niyo, yung signal na gusto niyo i-amplify. Itong voltage divider is the tawag dito is the power supply that will power the transistor. So bago nyo ginawa yung experiment sa transistor, ginawa nyo muna itong experiment dun sa voltage divider at pinag-aralan nyo muna yung effect ng voltage divider. So dito, ang voltage divider circuit nyo is given by a 12 volt source, 100 kilo ohm na resistor, tsaka 22 kilo ohm na resistor. Tapos you're taking the voltage across the 22 kilo ohm resistor. And of course, pag walang load yan, yung current, pag wala itong 470 ohm, yung current is 0. Okay? Kasi wala ka namang resistor dito, wala kang resistance yan. So walang dumadaan na current dito. And the reason for that is because itong voltmeter is high impedance. Okay? Meron siyang very, very high impedance. So sobrang liit lang ng current dyan. Or at least dito sa Simulink, 0 yung current. Of course, yung voltage dito without the load is 2.164 volts. And you can also verify that, okay, by simply doing yung, or by solving for the voltage across the 22 kilo ohm resistor. So it's 22 kilo ohm, oops, 22 kilo ohm, okay, divided by 100 plus 22 kilo ohm times 12. Ang makukuha nyo is 2.164. Okay, now if you add the load resistance, okay, so ang gagawin nyo di, anong magiging effect nung ano? Ano magiging effect ng load resistance? Okay, ang magiging effect ng load resistance ay, syempre, magkakaroon ka na ng current dito ngayon. So meron ka ng current na dumadaan dito sa load resistance. At ang current na yan is 117 microamperes. Okay? And yung voltage dito is 55 millivolts. Okay? So madali nyo lang din makukuha yan kasi ang mangyayari dito ngayon is magkakaroon ng ito is in parallel with this. So meron kayong effective na resistance dito. And because of that effective resistance, makakompute nyo yung current through the total resistance or the effective resistance. And once you know the total current, yun din yung current na dumadaan dito. Tapos once you know that yung current ay mag-split dito at saka dito. Okay, so you can solve for the current through here. Okay, knowing na yung voltage across this is 54.967 millivolts. Okay, so this is 54.967 millivolts. Okay, i-divide nyo yan by 470 ohm, ang makukuha nyo is 117. Okay? So, so by using a very small load resistance, ang mangyayari ay magkakaroon or tawag dito, nagbabago yung tawag dito, yung voltage across the load. Okay, and of course, it's not good. Okay, kasi remember na itong load na to, yan yung tawag dito, you want, ang load na yan, ang ine-expect niyang voltage is 2.164 volts. Pero dahil yung load resistor ay mas mababa kaysa dun sa, sobrang baba kumpara dun sa impedance nung power ninyo, nung power source. Okay, ang tawag dito, ang ginagawa ng load resistors, binababaan niya yung voltage. Okay? Okay, so, okay. Now, ang task na isang pinagawa sa inyo is i-increase nyo yung, or papalitan nyo yung load resistance in such a way na it is within 10% of the theoretical. Ano yung theoretical? This is the theoretical. 2.164 volts. Okay. 10% niyan is within 0.216 0.22. So ibig sabihin mga 1.9 something, di ba? 1.94 and then 22 ulit dito sa 2.38, di ba? So if I change this to 1 mega ohm, then I get 2.126, which is well within the 10% na tawag dito window na inassign ko para dun sa task na ito. Okay? Okay, so basically ang idea lang dyan is just to select a load, okay, such that walang loading effect. Okay, such that babalik tayo dun sa ang output voltage pa rin is 2.164 across the 22 kilo ohm resistor. Okay, so that's for part 2. What about for part 3? Now, for part 3, included na both yung DC source at saka yung AC source. Okay, remember na yung DC source ay magpa-power dun sa transistor ninyo at yung AC source, yan yung signal na gusto niyo i-amplify. Okay, so titignan natin ang experiment na to involves tawag dito yung ano ba makikita ninyo pag pinagsama niyo na yung dalawang signal. Okay, so yun yung idea dito. Okay, so ano bang nakita niyong result? So ang nakita niyong result dito is ang voltage dito across this load is about 2.135 and yung current as it goes here is about 2.136 microamperes. Okay, so this is 1 mega ohm, hindi lang nalitaw dito, pero this is about 1 mega ohm. And you can see that it's 1 mega ohm kasi if the voltage is 2.135 volts, then that means yung i-divide nyo to by 1 mega ohm, ang makukuha yung current is 2.136 microamperes. Okay, so theoretically, nagmamatch pa rin siya dun sa, anong tawag dito? Dun sa ina-expect ninyo. Experimentally, nagmamatch pa rin siya dun sa theory. Okay, now, ano pang mapapansin nyo rito? Ang mapapansin nyo rito, itong voltage na ito is actually, wait, ano bang ginagawa natin dito? 2.135. Actually, dapat, nagko-compute tayo with respect to this one, somewhere here, 2.12. Yung DC ang tinitignan natin. So, ang DC, okay. Ang DC is about 2.125, okay? Okay, kung papansin nyo, here, ang DC is 2.126. Okay, so ibig sabihin, nakikita natin yung DC signal dito. Okay, kitang-kita natin yung DC signal. Now, ang AC natin is 10 millivolts. So kung titignan nyo to, from here to here, it's about 10 millivolts. Okay, and then from here to this lower peak, it's about 10 millivolts. So meron tayong 10 millivolts na peak voltage. Okay, so which is consistent. So anong naging effect dito? Ang naging effect is meron kayong DC na signal na nakasakay. Ang nakasakay doon sa DC na signal ninyo ay yung AC na signal. Okay? So yun yung dapat na makita nyo dyan. Okay, so in other words, at this point, at this output, you'll see both yung DC at saka yung AC signal. So yung DC ay ito at yung AC signal ay itong 10 millivolts. Now you can see that it's also consistent, okay, pagdating sa current, kasi dito sa current, sobrang sensitive ng mouse. Okay, so dito sa current, makikita nyo from here, from the middle, the average to here, that's about 10 nanoamperes. Okay? So 2.125, 2.135, and then dito naman 2.115. So that's about 10 nanoamperes. Kasi expected naman yun kasi meron tayong 10 millivolts dito na AC, divide nyo by 1 mega ohm na signal, ang makukuha natin is 10 nanoamperes. Okay, so everything is consistent dun sa experiment na ito. Okay? If you have questions, type nyo lang dun sa sa question box, sa chat box. And then discuss natin mamaya. Okay, next. Okay, so yung last part ng experiment, okay, ay yung pag pinagsama nyo na. Okay? So remember na at this point, okay, ang DC is 2.126 at ang AC is 10 millivolts. So dito sa base terminal, okay, ang nakikita ng base is 10 millivolts na signal. Okay, at anong tawag dito? Yung 2.126 na DC voltage. Okay? So, anong kailangan natin gawin first of all dito? First kailangan natin i-compute yung Q point. So, when we solve for the Q point, ang una natin gagawin is yung Thevenin voltage at yung Thevenin voltage 2.16. Okay, yun yung na-compute natin kanina pa. Diba? Yan yung DC voltage. Okay, 2.12 or 2.16 ito. Oops, sorry. Okay, 2.160 ito. Okay, and bakit hindi na siya 2.126? Bakit 2.16 na siya? Well, kasi ang kinompute natin ay yung Thevenin voltage. Hindi pa natin tinitignan yung effect ng load dahil dito sa transistor. Okay, so RTH is 18.03 kilo ohms. Okay, so madali lang din yung makakompute yan. And from here, pwede nyo na i-compute yung emitter current. So ang emitter current is just yung Thevenin voltage divided by yung voltage across the base at saka emitter. So that's 0.7. Okay, kayo rin ang nag-set niyan. Kung nalala nyo sa experiment, kayo yung nag-set ng emitter voltage dun sa properties ng transistor. Okay, and of course, divide nyo to by the load by the resistance across the emitter plus yung resistance, Thevenin resistance divided by 125. Okay, so essentially it's the resistance here. Okay, kasi itong resistance na nakikita dito is 18.03 kilo ohm, okay, divided by 125 na K. Okay, so when you do that, you get an emitter current of 0.3014 milliamperes, and of course the emitter or the collector current is approximately the same. Okay, and from there, pwede nyo na makuha yung emitter voltage. So that's the voltage across this. Okay, ang emitter voltage ngayon is 1.42 volts. Ang collector voltage is 5.37 volts. Makukuha niyo yan from VCC minus IC times RC. Okay, so 5.37 volts. So ang VCE natin ngayon is yung collector voltage referred to the ground minus yung emitter voltage referred to the ground. So ang difference nitong dalawa is 3.95 volts. So ito ngayon yung ating operating point. Now, does this make sense? So kung titignan niyo ano bang saturation voltage nyo dito? Ang VCC sat nyo rito is 12 volts kasi yun yung input na voltage niyo. What about yung saturation current niyo? Ang saturation current is just VCC, okay, divided by 100 kilo ohm plus 22 kilo ohm. Okay, so that's about, if I remember correctly, kinumpute ko yun, hindi ko lang nasulat dito. About 1 milliampere yata. Okay, so that's about 1 milliampere. So ibig sabihin 12 volts. So kung magdo-drawing tayo ng load line. Okay, so annotate. Okay, so kung magdo-drawing tayo ng load line dito. Gamit ako ng ibang kulay. Okay, so magdo-drawing tayo ng load line. Okay, so ito yung ating VC at ito yung ating IC. So ang IC SAT is about 1 milliampere. Okay, and yung ating VCC SAT. Okay, so yan yung ating load line. And yung 3.95 nandito banda, tapos yung 0.3, okay, so nandito banda. Okay, so of course it's not to scale. It's not to scale kasi malamang mali yung computation ko nitong pero makikita niyo na banda siya dun, just a little to the center of the load line. Okay. So anong magiging effect niyan ngayon? Okay, so remember this is 3.95, di ba? 3.95. So ang ginagawa natin dito, okay, kung naalala niyo is we're inputting a signal which is very, very small, okay, 10 millivolts. Pili tayo na ibang kulay na contrasting. Okay, so 10 millivolts. Okay, so 10 millivolts lang yan. Exaggerated to, hindi yan 10 millivolts. So hindi ganyan ang width ng 10 millivolts. So pagdating niya dito, 10 millivolts. So yung 10 millivolts na yan, ganyan yan. Okay, pero ima-match niya ngayon dun sa load line. So ngayon sa load line, ito na ngayon yung corresponding na amplitude ng current. Okay? So ganyan yung expect. So kung ano yung amplitude na yan yung amplification o yung current amplification as a result of the tawag dito dahil dun sa load line. Okay, so clear ating drawing. Okay, para makamove sa next part. Okay. So, ito na yung summary ng results. So, for the base current, okay, ang nakita natin is experimentally is 2.652 microamperes and theoretically ang in-expect natin is 2.4 microamperes. For okay, and for the DC voltage is 2.118 and para naman sa yung theoretical naman is 2.16 volts. Sa emitter it's about 305.688 microamperes and yung theoretical is 301.4 microamperes. Sa collector is 301.4 microamperes din, okay, pero experimentally it's 303.3037. So they're not exactly the same. Okay, for DC voltage, is 1.418 volts. Okay, so theoretical is 1.42, and for collector is 5.334, and theoretical is 5.37. Okay, so first of all, ang pinapahanap is voltage gain. Ano ang voltage gain? Ang voltage gain is the collector voltage. Okay, dun sa AC. I'm sorry. Ako nga, hindi ko pa pala na-discuss na. So yung input is 10 millivolts. Okay. Yung dun sa emitter is 1 millivolt, pero dun sa collector is 1.851 volts. Okay. Sorry. Okay, so ito yung second effect ngayon nung tawag dito. Second effect nung, hindi, ito na may effect nung bypass capacitor. So kung titignan ninyo, okay, yung bypass capacitor, pinapaliit niya yung AC voltage. Okay, which means na yung voltage na nagsisplit between emitter at saka collector, mostly napupunta dun sa collector. Kaya mataas yung gain. So ang gain is taken from collector divided by the base. So 1.851 volts divided by 0.01 volts, that's 185 na. Okay, what about the AC emitter resistance? So the AC emitter resistance is something that you can compute from the collector resistance, which is 22 kilo ohm, at saka dun sa gain. So ang AC emitter resistance is 119 ohms. Okay? Tapos, ang AC beta parameter naman natin is computed from the gain between the emitter current at base current. So that's 85.06 microamperes. At saka 0.972 microamperes. So that's 87.51 para dun sa beta AC parameter. Okay. Okay, so now let's check for consistency. You can compute for the input base resistance, okay, in two ways, dalawa. Either from this, beta AC times yung AC emitter resistance, or simply by dividing the base voltage by the base current. Okay. So, okay, so makikita nyo na if we do this, ang makukuha nating input base resistance is 10.4 kilo ohms, and if we do this, makukuha natin is 10.3 kilo ohms. Which means na dahil pareho tong dalawa na to, okay, yung nakukuha natin na values dito experimentally is also anong tawag dito, consistent with each other. So we verified yung results experimentally, not just by comparing experiment with theory, but also taking a look at kung ano yung ina-expect natin na input-based resistance and using these two equations. Okay. Now, compare natin ngayon yung results na yan. So itong numbers na to is exactly yung results na nakita nyo kanina. Itong numbers naman na nandito is without the bypass capacitor. So without the bypass capacitor, anong nakita nyo rito? Tumaas yung emitter voltage, okay? Bumaba yung emitter current, bumaba yung emitter current, bumaba din yung collector voltage significantly. Okay? Of course, yung base current, base voltage is the same, yung base current ay medyo bumaba din. Okay, so ano ngayon ang ating gain dito? So ang gain is 45 divided by 10, which is equal to 4.5 na gain. So by removing the bypass capacitor, we have a gain of 4.5, pero with the bypass capacitor, we have a gain of 185. Okay, so ang effect ng bypass capacitor is to improve yung gain ng ating single stage na amplifier. Okay, so I hope yun yung results na makikita ko dun sa sa inyong report tsaka sa inyong circuit. Okay, and I think that's it for today. Ito na lang a couple of reminders. So, yung assignment, grouping assignment, okay, nagka-problema tayo dun sa submission ninyo, pero ang ginawa ko is binura ko yung activity na magsasubmit kayo ng experiment for, gumawa ako ng bago. So kaya nakapag-submit na kayo ng ano. Apparently, hindi na pwedeng baguhin yung settings once you change the group, once you assign a group setting there. Okay, so you shouldn't have any problem din sa pag-submit sa experiment 5, which will be in about 14 days, di ba? So about 14 working days. So, experiment 5, merong 4 parts: non-inverting, inverting, integrator, tsaka differentiator. Now, even though merong 4 parts itong experiment na ito, okay, hindi siya kasing tedious dito sa transistor. Okay, so actually medyo straightforward yung perform ng experiment with op-amps. And actually wala kayong babaguhin once you once na ilagay niyo na yung operational amplifier na block dun sa circuit ninyo, wala na kayong kailangan baguhin doon. Okay, just use it as it is. Okay? Basta sundan niyo lang yung instructions. Okay, okay, but dahil apat nga ito, you'll still need about the same amount of time as experiment 4. Yun lang. Ang sinasabi ko lang dito is mas madali na siyang gamitin kumpara sa dun sa transistor. Okay, and you no longer need to take videos of yourselves working together. Okay, I think 4 experiments is enough na makita kayo. Okay, na nagdaldalan about your experiments, and tawag dito, trying to contain myself dun sa mga maliliit na mistakes ninyo na sinasabi. Okay, and for experiment 6, tulad ng sinabi ko sa inyo, you don't need to submit anything. Okay, automatically you get 10 points equivalent para dun sa Simulink circuit na experiment, and then 10 points for answers to questions. Okay, so merong tanong? Meron kayong tanong? Wala. Okay, klaro naman. Okay. So, yes. Ano po yung theory na answer sa Q4? Okay. Oo nga, hindi ko. Sandali. Ilalabas ko lang yun. Nandun pala sa VLE. Ano. Sandali. I-open ko lang yung VLE. Sandali lang. Bagal. Okay, question number 4. What is the effect of the coupling capacitor? Okay. Okay. So, ano yung theory? Okay, so question number 4. Ano nga yung question number 4? Okay, doon. Yes, so ito yung theory na tinatanong mo. Asan na yung... Okay, so ito yung theory na tinatanong. Kasi ano ba makukuha ninyo? Ang makukuha ninyo sa experiment are these, di ba? Ito yung makukuha ninyo. So, i-compare niyo yan with theory kasi expectedly, ang ina-expect nyo actually dito is 10 millivolts, di ba? But you don't get 10 millivolts. Instead, you get 9.4. And in the same way, imbis na kanina ang nakuha niya, or earlier, or pag wala yung coupling capacitor, nakukuha niya is 21.2. Instead, bumaba yung current to 20.051. Okay? So, syempre, ang tanong dyan is bakit ito bumaba? Bakit bumaba yung current? So, i-compare nyo ngayon yan with theory. And it turns out na the reason kung bakit bumaba yan kasi merong voltage drop dito. And meron ding impedance yung capacitor. So, ang tawag natin is capacitive reactance. Di ba? So, meron kang small capacitive reactance dito. Meron ka pang resistor dito. It results to an impedance. Okay? So, yung impedance na yon, i-divide nyo by 10 millivolts gives you this value. 20 microamperes. Okay. So yun yung theoretical part na hahanapin ko when you do your report. Of course, hahanapin ko rin itong part na ito sa XC. Yung capacitive reactance, yung effect ng capacitive reactance. So, ito capacitor voltage. Okay, 3.2. Okay. So ano pa? Ano pa yung iba niyong tanong? Okay, so wala nang tanong? Okay, so kung wala nang tanong, I'll see you in, kailan nga ba? June 6? Tama, no? So, sige, I'll see you in June 6. And we'll make it a little bit less formal na katulad ng ginagawa natin dito. Okay, tapos gawin na rin natin parang tawag dito. Parang yung ginawa natin last time. Pero hindi tayo magtatagal, of course, dahil marami pa tayong ibang kailangan gawin. Okay? So, sige. Kung wala nang tanong, then I'll see you in a couple of weeks. Thank you then.